A projectile motion is a free flight motion following a parabolic path. So this is a kind of a curvilinear acceleration following a path that is parabolic in shape. So it works on the assumption that gravity is constant at any altitude, and the acceleration that acts on the motion is only the gravity. So this is the setup of a projectile motion. So this is the initial position of the particle, and this is the path of the particle, and this is the final position. So given that the only acceleration here is the gravity, which is equal to negative 9.81 meter per second squared, having downward direction, your horizontal acceleration is equal to 0. Therefore, the vertical component of the velocity is constant at any point in the projectile. So your Vox, or the initial x component of the velocity, is equal to the x component of velocity Vx at any point. So the velocity is fired at a certain angle theta. So your velocity Vo can be reduced into component, wherein Vo is the square root of Vox squared plus Voy squared. V equals the square root of Vx squared plus Vy squared. So now, knowing that we only have vertical acceleration, this may also cause some changes in the three kinematic equations of motion for constant acceleration. So first, for the horizontal motion, our Vx is equal to Vox. Now, we have our x equals x naught plus Voxt. So it comes from the original equation of v is equal to vox plus at, but we don't have acceleration, so ax equals 0. That is why this is the changes to the formula. Now, for the vertical motion, your ay is equal to gravity equals negative 9.81 meters per second squared. So, your Vy, or the y component of the velocity, is Voy plus gt. Your y is equal to y naught plus Voy t plus 1/2 gt squared. So this is the position as a function of time, and we have Vy squared equals V O y squared plus 2g multiplied by y minus yo, where Vx is the final velocity, or velocity at any given position. Vox is the initial velocity. X is the position with respect to the horizontal axis. Now we have here Vy is the final velocity, or velocity at any given point x. We have Voy as initial velocity for the y component. We have g, the gravity, and t is the time. So let's solve an example. A stone is thrown from a hill at an angle of 60 degrees with the horizontal at an initial velocity of 30 meters per second. After hitting level ground at the base of the hill, the stone covered a horizontal distance of 150 meters. How high is the hill? So let's establish first the coordinate system to analyze. So we have here your y-axis, and you have your x-axis. Now, a stone is thrown from a hill. So let's make this your hill. So this is the origin of the stone. Let's make this the top of the hill. Then it is thrown at an angle of 60 degrees. So this is your velocity with an angle 60 degrees at an initial velocity of, so your VO is 30 meters per second. After hitting level ground at the base of the hill, so the base of the hill is a level ground. The stone has covered the horizontal distance of 150 meters. So this is the path traveled by the stone until it hits the level ground of the hill, wherein your stone covered a horizontal distance of 150 meters. Now, how high is the hill? So we are looking for the height of the hill. So the height of the hill is this one, h. So with reference to the origin at y and the final position. So to solve for the problem, we need to identify the equations that we are going to utilize. So we have five equations derived from the kinematic equations of motion. So we have our initial velocity, 30 meters per second, x is equal to 150 meters, and the angle is 60 degrees. So let us first take the components of the velocity, initial velocity, Vox and Voy. So your Vox is equal to Vo cosine theta equals 30 cosine 60 degrees. So that is equal to 30 cosine 60, 15 meters per second, while your Voy is Vo cosine theta equals 30, or not cosine, sine 30 sine 60, and that is equal to 30 sine 60 is 15 square root of 3, or 25.98 meters per second. Now we have x, we have Vox. So let's use the formula for x. X equals x naught plus Vox multiplied by t. So x naught, or the initial position of x, is equal to 0 with respect to the origin. Vox is 15. So we can solve for the value of time. So we have x of 150 equals 15 multiplied by time. So t is equal to 150 over 15 equals 10 seconds. So the time of flight took 10 seconds. Now let's focus on the y component of the flight. So for the position y, we have y equals Voy t plus 1/2 gt squared, and our yo. So I almost forgot, y is equal to yo plus voyt plus 1/2 ut squared. So your initial position yo is equal to 0. So we have y equals Voy is 25.98 multiplied by t is 10 plus 1/2 times negative 9.81 times t, or the 10 squared. So here h is equal to y, or y is negative h. So y is negative h, knowing that h is below the x-axis. So we have negative h equals 259.8 plus 1/2 times negative 9.81 times 10 squared. So we have negative h equals 259.8 plus or minus 9.81 times 10 squared over 2. So negative h equals negative 230.7. So your h is equal to 230.7 meters, and that is the height of the hill.